Hi everyone, I C.S. Shanti, working as Assistant Professor in BVC Institute of Technology and Science Engineering College, another stream of Computer Science and Engineering. Here I am presenting a topic that is 802.11 IEEE standard. It is a Wi-Fi technology. Firstly, I discuss about what is IEEE. IEEE stands for Institute of Electrical and Electronics Engineering. IEEE produces various standards for LAN communication, and these standards will be called as 802 standards. These 802 standards are divided into different parts. Among that, 802.1, this standard is related to network management. 802.2, this standard deals with data link layer in OSI reference model. 802.3, this is a standard Ethernet model, and this standard is related for MAC sublayer for the network which will be arranged using bus topology. 802.4, this standard is related to token bus network. 802.5, this standard is related to token ring networks. And coming to the next one, that is 802.6. The standard is related for metropolitan area networks. That means wherever the network will be arranged or the communication will be done in the form of MAN technology, then we are using 802.6 standard. 802.7, the standard is related for broadband technology for the advisory groups. 802.8, this is a technology for the fiber optics. 802.9, it is integrated voice and data network standard. 802.10, it provides the security for LAN and MAN categories of network. 802.11, it is wireless communication. 802.12, it provides 100 Mbps speed wherever the LAN communication will be done. 802.15, it is for Bluetooth technology. Coming to the actual topic, that is 802.11, it is a Wi-Fi communication. Let us go for the deep discussion about 802.11. The standard specifies wireless LAN. It uses two different services. The first service is BSS and the second service is ESS. BSS stands for Basic Service Set. ESS stands for Extended Service Set. BSS is made up of stations and access points. Here the stations and access points are the components of BSS. And BSS is a radio coverage to form the station and access points in a network. What do you mean by station? The station is nothing but nodes. An example of nodes are mobile phones, electronic devices like laptops, desktops, etc. And access points. The access points are nothing but, so wherever all the stations will be connected in one communication line, that will be represented as an access point. Simply we are saying that access points are nothing but stations which are connected. Let us go for the basic diagram of BSS. So this is the basic diagram of BSS. Before that, the stations are actually arranged in two different types of networks. The one network is ad hoc network and another structure is infrastructure network. In ad hoc network, the stations will be arranged in a closed group. And here, the communication will be done within the network only. That means, if the station want to communicate to other station, there is a possibility of communication within this ad hoc network only. Whereas, coming to the infrastructure, whatever the station have to communicate, this communication will be done through this access point only. That means, so this is one type of BSS, this is another type of BSS. Whatever the data will be presented or the frame will be presented in the station, that will be sent by using this access point only. This type of network will be called infrastructure. So by using these two different networks, we are having communication of wireless based upon ESS. Let us go for what is ESS. ESS is made up of two or more BSS with AP. That means whatever the BSS having the AP, that BSS have to communicate. The group of all these BSS will be called ESS. For explaining this ESS, we need two more components. That component is portal and another component is distributed system. Let us go for the definitions of portal and distributed system. Here the portal is nothing but it is a bridge used in wide LANs. Whenever the two LANs are connected, for getting the communication of two LANs, we need one communication line. That line will be called as a bridge. Here the bridge named as a portal. And next one, that is distributed system. Distributed system is nothing but interconnection of network to form the logical network based on several buses. And communication of all these BSS will be done in a virtual view. That virtual view will be called as distributed system. Let us go for this architecture of 802.11. So this is the architecture of, and I am presenting how the communication will be done. What's the process of communication among these BSS? Okay. Now, first, suppose let us assume that one station at in one BS have to communicate with another station in another BSS. That is possible by using these APs only. That means, suppose assume that this station want to transmit the frame or a message or a data. Initially, we are taking it is a sender station, and wherever we are sending, that station will be called destination. So here the frame will be prepared here, and that will be defined in the form of a packet or datagram. After finishing its message, this station initiates access point, and whatever the data it has to be sent, this data initially sent to this access point. Here this access point will take the authentication of this station and the data, and this access point transfers the information to this distributed system. This distributed system again authenticates this access point and the station, and the information will be encrypted here, and whatever the data will be sending from this source station, it will be passed to distributed system and to another access point where the destination will be stored. And here the access point will filter the data packet coming from the station, and this after filtering, this packet will be sent to destination station. That means here what I am concluding is, whatever the stations have to communicate with other stations in another BSS, must and should that station have to transfer to access point only. And this access point, the data is transmitted to distributed system, and this distributed system, the data is transferred to another access point. From this access point, the data will be transferred to destination station. Okay, the communication between station of source to station of destination will be done. Station to access point to distributed system, distributed to access point to station. So this is the process of 802.11 architecture, and that is wireless communication. Let us go how the packet will be transferred, how the data will be transferred. That will be shown by using 802.11 frame format. Now I am explaining how the data will be transferred, in which way the data will be transferred. Okay, this is the process of a frame for the communication. Now first one I am discussing about how many fields the frame will be contains. Actually the frame contains 9 fields. That is, first one is frame control, second one is duration, and 4 addresses, and SC stands for sequence control, frame body, that is the data, and the next one is FCS, frame check sequence. Now coming to the first field, that is consists of 2 bytes, frame control. Now what do you mean by frame control? The frame control internally contains the subfields. Among that, the first one is protocol version. What is a protocol version? It is a 2-bit protocol it is a type of field which shows the current version of a frame, whatever the frame we are sending. And the next one, that is a type. It is a 2-bit field. It indicates which type you are sending. Okay, that means if you are sending 00, then the sending frame is a management. If you are sending 01, that we are sending frame is control frame. If you are defining 11 as a 2-bit, then the sending frame is data frame. Simply, type defines the function of a frame or the purpose of a frame we are sending. And this type includes the next field, that is a subtype. The subtype is nothing but it is a 4-bit field, and it defines 3 different types of functionalities. The first functionality is 1011. It stands for request to destination. That means, for suppose if the station wants to transmit the data, initially this station sends the request whether the destination will be free or not. That is done by using the 4-bit subtype, that is 1011. 1100, it is a clear to channel. That means before sending a frame, we must verify whether the transmission medium or the carrier will be free or not. To verifying that, we have to send the 4-bit of packet, that is 1100. Next, 1101, it is acknowledgement frame. After sending the complete transmission, showing or the representation will be done by using this acknowledgement field by representing 11 and 01. Okay, and coming to the next explanation of frame control field, that is 2DS from DS. These two will be studied whenever I discuss with this addresses. And next I am discussing about more flag. What do you mean by more flag is nothing but, more flag means it defines whatever the data we are sending in the form of a fragment. For suppose if we are sending the huge amount of data, we have to split the data. While we are splitting this data, we are dividing the data in the form of small fragments. After each and every fragment, we have to insert the one flag bit that will be indicated by using this bit, that is more flag. That means a more sending of data will be indicated by more fragments and by using more flag. And next one is retry bit. What is retry bit means? Suppose if we are sending the frame, while sending, if the frame will be lost. Okay, and we have to retry that frame. For sending of retrying, we are representing the bit as a 1 bit. For suppose if we are sending the frame for the second time, we are representing the bit as a 2. For suppose we are sending the third time, we are representing the bit as a 3. Now we are going for the more data. What you mean by more data is nothing but it is a set to 1, then the station want to send more data. Now next, WEP. WEP is nothing but wired equipment privacy. If we want to send the data in a secret manner, that means if we are sending any confidential data from source station to destination data, we have to encrypt the data in another code. When we are encrypting the data, we are using this field, that is WEP. And power management, it indicates the station in the power field. And reserved, it is for any excess of data will be there, then we are using the field that is called as a reserved field. Now coming to the explanation of next field, that is called as a duration. It indicates how much of time it takes for the transmission of data from one source to another destination. Now let us go for the explanation of addresses. Okay, here what do you mean by addresses? Among this 802.11 frame format, we are studying 4 different types of addresses. Let us come to the explanation of each and every address in a brief manner. First one is address 1. It is a random generated address. It is the address of BSS where the station is initiated. And address 2, it divides into 2 addresses, which are the source address and the destination address. Address 3, it defines the address of next station to be visited. Address 4, after frame transmission, it stores that the particular address where it come from, which station. Okay, that means present addresses of source and destination will be stored in the address 2, and address 1 where the BSS will be stored. BSS indication is address 1, the source and destination addresses are address 2, and address 3 is the next station address. Address 4 is previous station address. This is about the addresses. And when we are going for 2 address and 2 DS and from DS, these indicated as, for suppose while sending of data, if you are representing 2 DS and from DS as 00, it means that data coming directly from BSS to BSS. If it is 01, data coming from AP to BSS. If it is 10, data coming from BSS to AP. If it is 11, data is coming from AP to AP. So this is about the address tree representation. And coming to the next one, that is sequence count. Sequence count is nothing but it is a flow control. While transferring the frames, we have to increment how many frames will be sending. That increment positions will be represented by using this sequence number. Whenever the frame will be transmitted, the sequence count will be incremented as 1. That is about the sequence control or the sequence number. And coming frame body, the frame body is nothing but payload, whatever the data we are sending. And finally, what is FCS? FCS is nothing but it is a error detection and error correction method. While sending the data in the form of 802.11 frame format, if any errors will be there while transferring in the channel, in the carrier, in the source station or in the destination station, that will be detected and corrected by using the field that is called frame check sequence. So this is about 802.11 architecture and the frame format. Hope you understand all. Thank you.